There we go.
Broadcasting now.
Yep. Where are they now? And if you want the R Studio is available here with week 7 loaded up.
Awesome.
Oh, cool. Hi, how's everybody doing? Your response is how I feel, so all good. Hang in there. Today is going to be fun. I think today is actually going to be a really fun lesson. There's a lot of fun stuff in there that you might actually find useful, so let's enjoy it.
Could we have like a little bit of lights on? Is there like a tiny bit of light possible?
Tiny bit of light.
Well, I want to be able to see the screen, but I also don't want to fall asleep.
Is that better?
Ooh, lower. Whoa.
It's all or nothing.
Oh, really?
No, I'm just,
Oh, okay. Yeah, like that. Is that cool with people? Yeah.
how's that?
That's great.
Good?
I feel slightly more relieved.
We can make the screen bigger too, if that's helpful. Yep. Oh, do you folks have stickies? Name tags and stickies. Make sure to grab those.
Who's?
Yeah.
Yeah, losing our sticks.
What's that?
Laser kitties.
Oh, you can swap out your laser kitties if you need to.
Just hang it out.
Yeah, well, I was.
You're
I've seen all over.
Nice. That's what I was and then I can see Yes. I was like sitting there.
I know it's something.
Or like, so you enjoy Belgium?
All right, take another minute to jot down your pluses and minuses here. Okay, so sort of the theme of the things that you all liked that I'm getting is that maybe this is more of a what they call an authentic task in the educational psychology literature, right? Like this looked more like the kind of job that you're going to look or that you're going to do when you're out working with your own data, right? So that's great, and I'm seeing this plus 7 points for this being able to experiment. I won't speak for everybody, but this is absolutely how I learned how to code, right? Like I'll copy code from someplace else, I'll tinker with it, I'll try stuff and see what happens when I add or remove different parts of a plot generating set of code. So experimentation is really good way of like getting your hands dirty and seeing exactly what the code is doing. Reading in different ways of reading in data that makes sense. Yeah, we're trying to encourage, you know, sort of best practices and working with data and saving data, and we want to be able to encourage our colleagues to do the same. But you know, until we get there, being able to read data in different ways is good. Okay, so as far as the sort of muddier points, I guess I'm seeing. Oh no, let's see. There's some with 3. Get rid of the legends. Right. I'm going to show you all how we're filing issues briefly, because this is really important, right? This isn't just a technical piece, right? We want you all to get in the habit of filing issues, because as Ryan says, it's not an issue to file issues, right? It's good practice to be communicating with our collaborators about the code that we're writing, and so the way that I'm going to do that is to and probably the way this is logged in is Ryan. Let's see. So if we go to our ents team, and then up under the repositories, and let's say it was my job to file an issue on Ryan's, so I'm going to search for Ryan's repository. The issues button is right up here next to the code, and that's where we want you to go to file issues about the repository and about the different assignments for each week. So you go to the repository of your coding partner, go up here to click issues, and then over here for new issue to create a new sort of comment on their code, something that you think that they could work on, something that worked really well for you, whether the code successfully ran, those kinds of things. You look like you've got.
How is this workload different if we're outside of the GitHub classroom? Like, we graduate from this course, and then we have a collaborator in real life. How do we find their code, and how does filing an issue look?
Ooh, that's a good question. Okay, so I can tell you how I might do it, but you might be more qualified to say. Do you have an answer in mind already?
I think there's lots of different ways.
Lots of different ways. Okay, which sort of speaks to one of the other points that you all made about this homework too. All right, so here's what I would do. When I'm writing code with my collaborators, I'm often still emailing with them, and I will send them a link to my repository with that particular project. Alternatively, if you know their GitHub username and you just go to github.com, their base site, my username is that, M.I. Kuntz, and this is my sort of profile, right, with different repositories here. So these are all publicly available, and maybe that's another point too, is that right now all of your repositories are private to the outside world, but everybody within the ents team is able to see them. And so that's how they're visible to you when you go search for them and then try to file an issue on that particular project. But the sort of general pipeline looks really similar, right? So here's a project that I'm working on right now. Here's the issues tab. And all of you would be able to go find this particular repository and file a new issue on my chapter 1 for my dissertation. So similar sort of workflow, right? The issues button is going to be in the same place as long as you can find that person's repository. Does anybody know how, for instance, if I wanted this private, but I'm collaborating with somebody that isn't on GitHub, is that possible or not worth?
I was gonna say, if you go to the settings, so if you go back out to your repo where you are, and go up to the, I think you have to click on remote sensing to.
Okay.
Oh, it's because I'm logged. Never mind.
Oh, it's because we're logged in as you.
Yeah.
Right. Okay.
Why isn't it showing
Yeah.
up? So you could actually go to one of my reposts.
So.
Why don't you go to?
Oh yeah, that's all right.
Down here, do that one.
Ready?
Sure. So this is actually a good example. This is a website that I built for our lab, a bunch of like methods. But if you have made your own repo, or if you have been given access to a repo, you should see a settings tab. So if you click on that settings tab, and then there's all these options, right? The main one, if you want to look here, collaborators. And so, oh, sorry. Of course, this actually was a question. So here's a good example, right? We've added these folks to our repository, and if you look at each of these options, whoops. You can actually add them in a way where if I wanted to add somebody, you basically would type their username in here. And then the nice thing is you can actually just say that they only have a read ability, right? So you could add somebody that maybe say a student that you want to look at your repository or play with your data. And you can do that in a way, I think even with a private repository where you add them as a collaborator, but you only give them read access. And then they can actually see your private repository. They can pull all the data down, look at it, but they can't actually push any changes up, okay? Even if you give them read-write options, just the way these things work, you can do that in a way where they have to sort of file. We haven't gone over it, but there's a way to use branches and pull requests, which is what Mike and I, there's a lesson on the website actually about that, where so far we're all working in one branch on our repositories, right? One master branch, everything goes there. However, the way GitHub works, one of the cool things you can do is you can actually make a separate branch, do some stuff on it, and then merge those changes back in. And you can do that with multiple people. So you can have somebody who's working on a different branch, and then they say, actually, I want to pull my changes back in. And so to do that, they file a pull request. So that's one potential option to collaborate. But I think even in a private repository, I think you can give somebody, you can make them a collaborator, and then they can see your, just like we've done with ours, right? Everybody can see your repository and look at your code, but not necessarily push changes up to it, right? So it's really flexible, and the sort of how you do that, I don't know, Taylor probably has some ideas too, is people have different pipelines for this. What are your thoughts?
I think the things that you've shown are great introduction to this topic. And
Yeah,
if
right.
you want to start a big repository and project and that sort of thing on GitHub, maybe we should talk about that more in depth for your each like case. There's 2 help hours that you can come to. One is data-vis group 10 to 12 on Mondays. The other is meet and analyze data from 3 to 5 on Thursdays.
Ooh, hang on. Let me add that in.
So do you guys only really share your scripts through GitHub anymore personally?
Yeah, for the most part, I do everything through GitHub. It's really changed how I honestly, when I started, I was resistant initially, and once I started using it, now I can't really imagine not doing it because of the way you can control what you push. It's not like Dropbox where it just syncs everything, and it's way more flexible in how I track how things change. So, and I think more and more you're seeing like publications ask for a GitHub repository. You know, journals are using that. Like it is becoming much more widely accepted as a place to like put code. So yeah, I think it's you don't have to be like a whiz at GitHub to still use it and be really like still you're on the cutting edge of like what science is doing right now or pushing folks towards being like open source and transparent in how you do stuff.
Having version control, you don't realize how important that's going to be until you ruin your whole code and have
You're
pull
right.
the old version back.
You're right. So something
That would be
breaks.
last week.
Nice.
It's okay. It's all okay. Yeah, I want to echo that sentiment. So I came into GitHub and version control pretty late in learning how to program, and it's made me a lot more mindful, I guess, about my projects and about the code that I'm writing. So I'm more careful. Rather than just put something out there and write code and then sort of walk away from it, I do a better job because I know it's going to GitHub and it's being shared of filling in comments and writing exactly what I'm doing and trying to make variable names that aren't just like test 1, test 2, test 3, that sort of thing. So it has fundamentally changed the way that I work on projects for the better.
guys want to forget or something?
So,
I know, it sounds like it, right? Well,
I'd be happy to work for you.
43 stickers.
Are you offering a job? Right, and so back to Taylor's point too about there being multiple pipelines, sort of multiple ways of doing this stuff. That theme you might see over and over again, right? This point here about, you know, the dplyr verbs or the tidyverse functions versus base R. There's often more than one way to do things, and you know, I think you're going down a path to make yourself sad if you start thinking that one's always better than the other. It's good to know them both because people use both of them, and often the distinctions are you know, subtle and maybe not that important for your particular use case. Was there a specific questions about? Right, so 3 of you were mentioning that more about write table and write.csv too, right? So yes, the answer is yes. They both could be used for the objective, and they have, you know, slightly different.
In my assignment that I posted a sort of both ways.
Oh, gotcha.
Show it with
Okay.
a little info. So if you haven't checked out my repo, tidyverse repo, feel free to take a look if you want.
All right, and so some of these seem like kind of specific things. Does anybody have something specific that you want to see up here? That whether it's listed or you know, go more in depth. Not.
If you haven't checked out Mike's or my sort of our post for this week 6, please take a look. And if you still have questions, feel free to ping us again. And we can, or even after class, we can happy to chat. We want to kind of dive into the lesson, I think, instead of spending too much time going over the homework assignment, if that's okay with folks.
Sound all right?
Is that cool? All right.
Okay. So then the other thing that I wanted to highlight here, sort of housekeeping. So at the end of class, we're going to ask you all to fill out this survey. We'll mention it again about what sort of topics you may want to see, as you know, for a final week or two, we might have some flexibility to sort of fit the course more specifically to the kinds of topics that you want to see. So we're going to send that around. And then the office hours, Taylor just mentioned this. Meet and analyze data. What time and where, and how can we?
3 to 5 p.m. On Thursdays in the Bennett conference room of the Center for. I can open that.
Okay. We can add that in. Right. So we want you all to be able to walk away from here with you know, a working setup on your computer and sort of basic understanding of all of these things. So please come see us or ping us or email us, whatever. These 3 times are great to come find us, and we're happy to sit down with you one-on-one and work through your specific questions. So the data-vis users group, I've set up Thursdays from 10 to 12 in my office as a sort of office hour specifically for this class. And then what Taylor's adding in, the meet and analyze data, is through her lab group. That's another good outlet too. All right. All right. I think we should do some visualization. Yeah.
Yeah.
Ready for it?
Yeah.
Okay. So I will turn it over to you then.
Okay.
And yeah, what do you want? I'll let you.
Yeah, player. I don't know. Okay, so I'd like everybody to go to the data-vis website, which is I don't know if it's linked in here, but you have it bookmarked. So let's go to the website. Okay, and then today we're going to be sort of in 2 different places, and they're both in the course materials. So if you click on course materials, and then we're going to start with this lesson, visualization do's and don'ts. And then right below that, we're going to do literate programming with R Markdown. So today we're going to do some R Markdown. We're going to play with some really cool plots. So I'm pretty much be walking through this for the next few minutes. We'll do some live code stuff as well in a second. But I just want to talk about, now you have the capability to make some plots and Some plots might be better than others. There's some reasons why you might not want to do certain kinds of plots. And so I just wanted to, there's some really great folks that have worked on this before. And so I just want to talk about that. There's these amazing figures from long ago. This is a map of the effect of temperature on Napoleon's invasion of Russia through time. So it actually has 6 different types of data in one plot. So distance, sort of Latin long, directionality, temperature, and dates of the troop movement, which is pretty amazing. It has this like sort of a long profile faceting over here. Anyway, it's a really nice figure, right? And one of the things that makes it very easy, even like hundreds of years later, is that it's very clearly labeled, even in this very tiny, very amazing font. It has distinct sort of pieces that are labeled, you know what the different things are. And it has a very nice sort of legend / title, right? So it's very interpretable. Like we can sit down and look at this, and maybe initially we're like, whoa, there's a lot on there. But if we take a minute, we can actually see what's the story that person's trying to tell all in one plot, right? Which is the whole point of communication, of this sort of, remember the little plot we had of like bring your data in, clean it up, do some modeling or whatever, and then you want to communicate that and visualize it. That really fits within that sort of communication side. Similarly, there's another one that now is a very famous plot and example by Florence Nightingale, which is now called the Coxcomb chart. This is from 1854, and it's essentially showing the the effect of disease on mortality of troops. Or essentially, she's just looking at mortality in troops, and then what was disease versus just they died by bullet wound or something like that. Essentially pointing out that disease was a major factor in certain months of the year, and that was something that they might be able to deal with. And that really sort of revolutionized healthcare in many ways. Another one, this is another classic chart you'll see if you start looking at like famous visualizations, is a guy named John Snow, not from Winter is Coming, but cholera deaths, dot map of cholera deaths in relationship to where the drinking source was. And nobody, I mean, nowadays it seems very simple, but nobody had actually looked at that before. And so these are actually bar plots of how many cases they had. You can't really see it on the screen, but they're actual individual kind of lines that stack up so they can say how many, and then where that was in relation to a given water source. And there are little wells on here that you also can't totally tell from the screen, or at least I can't see them. But anyway, the point being that they could sort of determine like, hey, there's all this cholera here, and there's like a water source, this one's infected, versus over here, people pulling water from this well were not coming down with cholera. So lo and behold, maybe water, clean water, turns out to be an important thing. So data visualization in R. So there's a whole bunch of really great resources. Hadley Wickham wrote a really great paper sort of about the fundamental rules or principles of visualization, and that's what he based the ggplot2 package on. And one of the best quotes that he includes in that paper is that a good grammar will allow us to gain insight into the composition of complicated graphics and reveal unexpected connections when you're looking between seemingly different graphics, which is kind of a nice way to say, you can tell a really good story that someone else may not have seen before if you have a very nice plot, right? Something that is clean and easy to see. So I'm gonna wait this so it cycles back around. I think one of the best things that this all boils down to, what I've been just talking about for the last 3 minutes or whatever, is essentially keep it simple. Okay, so this I think is a really great little animation. It's gonna cycle back around towards the end, but it just talks about why and how. Like if you watch this for a second, it keeps simplifying things, pulling things off of the plot. And the funny thing is, there's another great graphic, I didn't include it here, but so this is like your traditional Excel chart, right? Like that everybody used for a long time. And the reality is the best option is often to pull all that stuff off of there because it's not relevant to the story you're trying to tell. And so in this case, they're comparing different food types, but if you notice like the 3D special effects, you really don't need that to tell your story. The labeling, you want people to see the data here, not necessarily the lines behind it. And so anyway, on and on, it sort of keeps iterating through and ending up with this, what turns out to be a very simple plot with the labels directly on the bars, right? Point being, keep it simple. So ggplot, you can make some crazy, complicated, awesome plots. Do you need to? Maybe not. So just think about that when you're making, particularly when you're sharing this or making a publication relevant plot. And I would argue if you read some, I mean, most of us have probably had to, slog through some science and nature articles. Think about how many crazy visualizations you've seen in those science and nature articles, where I would argue that one of the things that makes those articles like publishable is they think of like what kind of crazy plot can I put in that's going to grab attention, but it may not actually be the best visualization to tell the story. I think some other journals actually have much better graphics and figures, or much authors do that because it's very simple. I actually don't like some of those, like it takes you 10 minutes just to interpret what all is on the article. That's my personal opinion. I see some heads nodding, but I know there's reasons to pack as much as you can into one figure, but you lose a lot that way sometimes. And you lose a lot of readers who are not going to want to sit for 10 minutes and interpret what it is you're trying to say. So ggplot, we've talked about. I want to talk a little bit about color, because there are so many options for color, and it's really fun. But keep in mind, not everybody can see the same colors you can. This is a really great example. For some of you, you may not actually see that there's numbers inside of these circles. And that's because it's fairly common to have absence of blue or green retinal receptors. So blue-green color blindness, particularly in males, is more common. So there is actually 74 and 29 here. There's many other iterations of this that you can test for color blindness. But anyway, I think there's something to be really cognizant of. And the other thing is when you print, oftentimes print stuff out, you're printing it out in black and white, right? So a lot of colors don't translate well when you're trying to print out in grayscale. So there's some really great palettes that you can use to get around this. There's this really great cheat sheet I've linked to here. Having said all this, I'm going to show you like the crazy cheat sheet of colors in R. This one is my favorite because I think it is really flexible and it has a lot of options. So it not only has these single 3-digit numbers, but it also has the actual name. So in any plot, if you put these names in a quote, color equals this, it'll show up. The other nice thing is it actually gives you the RGB values here, which is also nice if you're trying to match some web sort of related things. And similarly, this hex code, which is starts with a pound sign and it's usually 6 sort of alphanumeric characters. And anyway, so you can look up a whole slew of colors. I mean, look, there's like gray, basically 0 through 100. You can play around with these as much as you want. When you turn on transparency, that alpha in ggplot, it also affects sort of these colors and how they appear. But there's pages and pages and pages of colors, which is really fun, but also sometimes not ideal.
Can you type in the number for the color?
You can actually use the hex code in ggplot as well. Yeah, I think it has to be quoted still, if I'm correct. Cool. Any questions so far? Now I'm going to dive into some actual color palettes that folks can use. So for discrete and categorical data, there's a number of options, but one I find really useful is this colorblind palette that's part of the GG Themes package, which we mentioned previously. So it's linked here, so let's go ahead and check it out. This is maintained and has a whole slew of themes, and there's even more themes in addition to this, but theme 538, if you really want to go Excel, you can do a theme Excel, replicating the classic Excel charts, just to make you can tell people, no, I really made this in R, and they won't believe you. So anyway, there's a whole bunch of these, Wall Street Journal, Tufts, Stata, Solarized, etc. But I want to point out these right here. There's a bunch of scales. So in ggplot, we can use scale, and scale can be used for anything that you're mapping to an aesthetic, right? So think like inside your AES call, if you're mapping some variable to color, fill, shape, size, all of those things you can map to a variable. You can use scale to tweak it, to play with it however you want. So it'd be scale underscore fill, scale underscore color. Anyway, the one here, the scale color colorblind, is a really nice palette you can use for about 8 to 9 variables, discrete variables. I'll show an example here in a second, but I really like that one. I use it quite a bit, and it prints well in black and white as well. Okay, so where were we? And then Viridis. So the Viridis package, this is the base Viridis color plot, and it's pretty amazing. So Noam Ross, who's basically the founder of the Davis R users group and was an ecology grad group fellow, now is out in New York. He and a couple other folks helped design this package, which is just the Viridis package. You can install it, and then the nice thing is it has this really nice color palette that has been designed specifically to be very legible and clear for various types of color blindness. And it maps well for printing. Anyway, there's a whole slew of sort of why, like they have 4 main palettes. They just added this one. This is another specific one for folks with a specific color blindness. But you can use any one of these palettes, and I think it's really good for, particularly for continuous data. You can use it for categorical data, but it's not as, it takes a little more tweaking. Anyway, it's really nice. If you compare it to some of the base palettes in R, Rainbow is really generally an awful palette to use for a number of reasons, but you can see, look at the ends are like the same color. So anyway, there are some reasons you might want to stick with some other options, but Viridis is really a solid choice. And more I'm seeing this in publications all over the place. NASA's using it now for their, recently I saw a satellite, or one of their telescope images, they actually used a Viridis palette to show like a planet, which was really awesome. And Noam tweeted it out, and he was like, look, NASA's using this package, it's great. So anyway, it has a whole bunch of interesting stuff about what these different color blindness see, like how they would see these different palettes, right? So which is really fascinating because, you know, if you don't have that, you're not aware of that. And so I think just looking through this is really pretty cool, thinking about like what do people see versus what I see, and how can you change that? So blue blind, you know, they see these reds, but this palette just changes completely. The ggplot default is just all dark, so that's another thing to consider. Anyway, stuff to think about. Yeah, you had Mike.
I actually was recently working on doing an RStudio theme that was colorblind, like safe, and there's a cool app you can download if you're like interested in this, which I think is something that we should all try to be aware of. There's this app called Color Oracle. So it's just a little thing that pops up in your toolbar on top, and then you can select different types of color blindness, and it'll put your screen as it would appear. So like any visualization you're doing, anything you're working on in any setting, like outside of R, inside R, whatever, it'll show up like that, and you can look and just do a quick check, and then it goes away just like that.
What is it? There's a website that's similar to that. That's Color. Is it Color Brewer 2? Here it is. This one is awesome. I use this quite a bit. Come on. There we go. colorbrewer2.org. So if you pop this open, what's neat is this automatically updates, and you can play around. So it's not great for continuous data, but for categorical or factor stuff, it's great. But you can play around with the diverging, qualitative, and you can tweak things to say, like, I want it to be colorblind, printer friendly. You know, the more things you click, the less options you end up with. But what's nice is it actually gives you, you know, these little counties or districts that you can look at and see how the data will actually look. And then it gives you the various options. You can do RGB, the hex code, or another one. This is CMYK, which is just another type of code essentially for your data. But it's nice. I use this. I've used this quite a bit, and you can go up to 12 data classes, but you can see there are none that are colorblind for qualitative. For diverging, there are a few. and then sequential, there's far more. So anyway, this is a good website to sort of bookmark. Any questions on that? Okay. Yes, Mike.
If you all have 20 minutes, 20 spare minutes, go check out the video. There was a conference talk given about how they developed this particular palette. It involves everything from vision science to how the electronics and the monitor are presenting the colors. It's super cool.
It's fascinating.
Cynthia Brewer.
Yeah.
That's all this.
Yeah. It's pretty awesome. I think it's just really, visualization in general is really fascinating. I mean, if you think about like most of the information we see that our brains are taking in is visual, even if we're not totally aware of that. That's kind of just that alone to think about is really, really fascinating. And so because of that, thinking about what you're putting out there as a figure can make a big difference in how your work is perceived, right, and understood. So, and we like to hear a good story. So I often think of like, what story can I tell with this figure or set of figures? Okay, so I've made a few visualization do's and don'ts here. So there's these tabs, you can actually click on them. And so the main things I think to think about is, labeling appropriately whenever possible, using colorblind palettes, keep it simple as much as possible, reduce the sort of unnecessary clutter. So if the labels are not required, don't use them. Whenever possible, start your axis at 0. Don't sort of tweak your axes so you're like between 2.34 and 6.25. And really include your data and your outliers whenever possible too. That's a really common one that you see people call out very publicly sometimes, and people don't do that. And then a few things to avoid, 3D charts, high contrast colors like blue and yellow or red and green. The other thing that I've started realizing more, doing more of is don't add color unless you absolutely have to. You can map shapes actually to up to like 4 or 5 different data types in ggplot quite easily. And then it makes it really easy. You can plot it in black and white or color, it doesn't really matter, or combine shapes and color. And that can be really powerful. It makes it very easier, much easier to see. Okay, let's look at a few examples. So I've put some code in here. I'm adding this suppress package startup messages so that it doesn't print the whole slew of things that when you load ggplot2, it won't print. So let's try this code and see what we get. So we're going to use the iris data set, which is it's part of base R. So let's switch over to our, where'd it go? Here we go. Visualization. Okay. We run this plot, a base plot in R, and we get this very plain sort of 3-tiered thing. We don't really know. We know petal width, and there seems to be 3 groups, but we don't know much beyond that. So what if we want to learn a little bit more and try to provide some more information? One of the things we can do, let's put that into a ggplot. So using this same iris, so let's try this. Okay, so we're going to use ggplot with points. Now we're going to include data and split out petal width and petal length. Okay. Okay. So, can everybody see that? Or should I make this bigger in the back? Bigger? Okay. So notice I'm not adding any color. Oh, I need to load the library. I'm not adding any color. I'm just doing the default plot. So how could I, before we add color, what could we do to discern? So just to give you a sense, this is of flowers, right? And it's petal width and petal length. And there are actually multiple species in here. So if we look at the iris data set, let's use head of iris. You can see there's sepal, width and length, petal length and width, and species. So what if we want to look at this without any color? How can we discern, make this plot easier to see by species? Anybody?
Use shapes or transparency.
Huh, I hadn't thought about transparency. We could do that. So where would I put those? How would I do that?
Inside your AES column.
Inside. Why not outside?
Because you're calling a variable to map the.
Mapping a variable, right. So let's try this and see what we get. So let's try shape equals species. There you go. So now, suddenly that becomes quite a bit easier to see. There's still sort of in here, you can see that that might be an issue. So maybe, yeah, maybe we should do size, play around with size. And again, I'm putting it inside the aesthetic. Anytime you put something inside the aesthetic, it's assuming it's mapping to a variable in that data. Okay, so size equals species. Notice the warning, using size for discrete variable is not advised. Well, that's kind of why. Okay. So we'll make a note here, not ideal. Let's copy this and make a new plot. So now let's do something just as an example, because I saw this. So I'm going to remove size, but let's put alpha. Say we want to do the alpha. And let's make it 0.5 or 0.5, yeah, 0.5. Huh. What happened there? So this is in the live code. I just saved it for week 7. What happened there? Why is alpha it's showing alpha here, 0.5, but it's not, and it looks like it actually did 0.5 alpha for everything, but that's not exactly what I wanted.
Outside, it should be outside.
Right. So it's actually trying to map. It's basically assuming this is a data point. So it's sort of intelligently applying 0.5 to everything, but it's also, because it thinks that it's mapping this similarly to a variable, it's actually put it in the legend, right? Whereas if I move it outside of the parentheses, so if I put it outside our aesthetics call, let me move this, hit enter here. And then let's close our parentheses, comma, and then this is below that. Let's see what it does. Now alpha actually disappears from our legend, right? So if we have a legend, it's mapping to some sort of variable if it shows up in your legend, okay? But if we want to do alpha inside species, and again, it's going to say not advised for a discrete variable. So now at this point, maybe color is probably a good idea, right? Because we've sort of played around with this, but having shapes and colors actually might be a really great way to do this.
Wait, why did it not?
So,
oh, you should change the alpha to species. Never mind.
So notice that because we're using the same data here, so it's named the exact same, species and species, notice that it's actually it's put it all together in the same legend, which is kind of nice. So if you keep your legend name the same, it will, when possible, it will sort of put them all in one. Similarly, like if we had points and lines, and we were mapping the same thing to species, you might have a point here and a line through each of these, but it'll put it all in one instead of separate, lines and points. Does that make sense? Ish. Yeah, go ahead.
So all that's doing by saying alpha equals species, that's just setting a different transparency for each of the species variables.
Exactly. Right.
But then one of the species is more difficult.
Right. So this one is almost invisible, right? It's Setosa, and it's barely, only where it overlaps can you see it. But yeah, it's essentially somehow arbitrarily probably doing like 0.3, 0.6, 0.9, right? Like just splitting it across your. That's why it's saying it's not a great idea to do for discrete data. Okay, so let's add Viridis. So let's install Viridis if we haven't done that. Okay, and then loading Viridis. Now it pops up. Great. Okay. So now let's do our ggplot and do the same thing. And then after this example, we're going to switch gears a little bit.
Anyone else have an issue loading?
Oh, green sticky or red sticky's up if you were not able to install Viridis. I should have started with that. So if you can't get Viridis up, red sticky's up. So there's one in the back. Emily's got one. Anybody else? So I'm going to take the same plot and apply Viridis to it. So let me move this up a bit so you can see it. So if we want to use our Viridis color package, what do you think we should map it to? So remember the scale I was talking about? Scale underscore something. What would be the best one to use? Color. Well, so based on what I have, sorry, I have fill and shape.
What's the fill?
I'll show you the difference in a sec. Very small, so I can't see it totally right now. So let's try scale shape, and then we'll do scale color, okay? So scale shape. All right, we've got some red stickies. So let's pause for a second. Why don't we're gonna take a 5-minute break and just after this example. So why don't we take a pause on the helping and we'll fix you up. But I want to show folks this just so you can see how this is done. This is in the live code, and then we'll focus on getting people installed. So scale underscore shape, scale underscore, I don't know if you saw, there's a whole bunch of these options. Scale underscore, okay? Notice you can play with the alpha, the color, fill, right? Whole slew of things. Since we're using fill here, let's use that. And also, what's the difference between fill and shape? Well, as you'd expect. Now we just have the scale underscore fills. If we scroll down, because we have loaded the Viridis package, there should be a scale fill Viridis there at the bottom. Okay. Notice there's a C and a D. This is a newer thing that they've added. What do you think that is?
Continuous discrete.
Exactly. Right. So if you had discrete data, you could use the discrete scale, which is nice. So our data is continuous, I believe. Or no, actually it's not. The species is continuous or discrete? Discrete. Right. So let's use that one.
But Ryan, those were in ggplot, right? Those Viridis calls that you just.
These are all part of, because this has been loaded, it's now it's actually still part of this package, but it's available in ggplot. Yeah. Okay.
I don't have those options.
Yeah, they're not showing up for me.
So make sure you've loaded the library.
Yeah.
And then we'll look at it at the break in a sec, but I just want to show you what it would look like. So that's all I need. This is the most basic thing I would do is this. You don't need to put anything in there. You're just saying use these colors for that bit. Except it didn't work. Shape, fill, oh, because I have shape. Sorry. So fill is the inside part. So there you can have hollow points. So let's look at this. Again, error. So what is happening?
Value supplied to continuous scale.
That's what yours is saying. We can try C. Nope.
You have to use shapes that are hollow, or
You don't. So let's do color. The problem is now I need to change this to scale color. The joy of live coding. Sweet. There we go. Whew. No, you can actually use fill. I'll show you what I forgot to do. I forgot to, yeah. So this is discrete color, okay? So let's add this at the top. Use discrete colors as, here it is. What if we want to use fill? So I'm going to do the same thing. So now instead of color, I'm going to actually use fill. Now here's the trick that I was not including before that I just remembered. Fill, there's a whole bunch of different shapes in R, right? Point characters. And I think point CH? If I do help for point CH, let's see if it'll tell me what the different kinds are. Point values, it's numbers. Here we go. So it tells me a little bit, but here we go. That's what I'm looking for. So it actually says, so solid circle, filled square, there's all these different options. Do you see these down here? So these 0 through basically 20 are solid, so you can't use them for fill. The ones further over here, 21 through whatever they are filled options. So you have 1, 2, 3, 4, 5 options potentially. Okay, so that's what I'm mapping to. That's what I'm using is essentially these base point types. And so let's try 21 since it's the hollow circle. So now I'm going to use point character equals 21. Now this should hopefully work. I need to change this to fill, not color, because it won't map to anything. There we go. So the cool thing is now you can actually change the colors on the inside independently of the outside. So we could make the hollow circle, the circle outline, different colored if we want. You can play with the alpha a bit more with these, which is kind of nice. So you can totally play with these as you like. One other thing that I would point out is inside, if you want to change your legend name, you can do that inside any of these scale color or scale fill by just saying flowers, let's call it. And it changed our legend, okay? Because it's mapping this species to this legend. And that's why you can switch it up. Okay, let's take a 4 or 5 minute break. And if you need help with Beardus, let's get you set up. And then we're going to do our markdown when we come back.
So everybody's having the same problem. I think there's a issue with units talking to each other. So they need to install Beardus Lite, restart the R session, and then install
Really?
Beardus.
Huh. All right, so do Beardus Lite and Beardus, I guess. That's interesting.
Yeah, you did. It's like, I think it's calling on the wrong version of Beardus Lite. But Beardus is the newer version of Beardus Lite to get a version out of it.
Wow.
You're having that issue right now, right?
Don't you fix it?
Yeah.
It's saying one or more packages, so like restarting R, or should I restart it?
Oh, you already
Oh,
So this,
Really settled it.
well, no.
Color
So
and
this
field.
works different.
So doing that's trying to change the.
Is that the actual, usually it's the username?
I would guess.
So
But it's not. So try putting
I wouldn't use, that's not the owner of the,
and then
it has to be the owner of the,
now,
yeah. No, it has to be whoever, right, yeah.
So we got it from
That's like they copied it over. I wouldn't use that. But that, I mean, you can't, that's how you install stuff from GitHub.
So that's
Yeah, I just don't know. That's not the people who wrote the message. That's basically like some person who I don't know. So, okay, so that's good. So it's this Civitas. So yeah. So wait, you're going to slide and then.
Yeah, it needs to be reinstalled because I think there's like a update to it.
Okay.
And now there's the
All right. Well, fire away.
So she's not calling the proper Veritas Lite from this update to Veritas. And so it's looking for a function in Veritas.
Oh, yeah.
Is that what Veritas means?
right.
It's not there.
Yeah.
So we could access it. It's calling for a version.
Yeah,
So
exactly.
it says fire in order
What do you
Veritas
think?
Lite.
Yeah. Okay, so I can try and answer yours.
Okay, that would be great.
So it worked in B and we had a favorite.
Well, it's like a big deal.
Yeah, I don't really track on it.
So,
Yeah.
I like love that.
So it is valuable.
That's working fine. So if you do Veritas Lite first and then Veritas, and then you only have to load this Veritas package because it's called Veritas Lite. It's because that new Civitas. Take another minute.
That's what's happening
So you see how it's.
Right? I know. We're supposed to be So I didn't feel training was like.
It hurt for us.
It wasn't actually that.
So the function is, I have a schedule. So, really quick, let's have everybody back here so we can get going as coding goes. Take off that. So there might be a function that is not available on the new, I might have a very new ggplot or something. I'm not really sure why, but it seems like, so the previous version of this didn't have this handy D or C option. And what you had to do, so if I try to run this, let me show you. Discrete value supplied to continuous scale error, right? That's what a lot of people are getting. Great. I mean, not great, but great. If I hit tab inside this function, let's look at the options. So you can play with the alpha. You can actually play with the beginning color and end color, direction, so you can switch the option. So this is actually really handy. You can switch the color palette direction. Discrete. Notice that it defaults to false. So it always defaults to continuous. So what I would like everybody to do is let's go to discrete and type true. Now, if you try it, that's what I wanted to hear. Good. Now it should work, hopefully. So green sticky's up if that worked, and a pink sticky if not. Okay? And I apologize for there we go.
Oh, wait. Oh, yeah, okay, so when I have the, oh, that outside, as 21.
Yeah.
Okay.
I mean, I gotta figure out. Yes. Oh, I see.
Fill, so color is just like for a solid dot or any shape, right? That's the color. But there are shapes that are hollow, and so color is actually the ring, and the fill is the inside part. And there's like 5 or 6 shapes that follow that. That's why for that one you have to set it to one of those shapes. So like 22 through 26 or 7 are those hollow shapes. Yeah. Yes.
Doesn't work unless you.
Yes. I'll even type a note in here. To use, we set to a point height or.
That's why all the points have a black outline on it.
I don't know, 21 through like 30 or 28 are hollow. The shape. So there are ways that you can do hollow. So we could do this where we could make a different hollow shape for each color, or we could just do color and shape separately. So why don't we try that? So one more, combine color and shape. So this gets into the sort of, now you were really starting to play with the visualization. So let's say we want to do, we're going to take our species and map by color and by shape. Okay. And I need to change this color palette now to color and not to fill. Because if I run it with fill, nothing's going to happen, right? There you go. Notice what I talked about previously. What happened here? Look, because I named this differently, notice I made a different legend. So in this case, I would want to make sure it's going to default to whatever the exact name is. So if I take that out, or alternatively, I name it exactly what I want, species, which is the same, it's spelled the same as the column header. There you go, now it's all in one column, or on one legend, sorry.
Wait, what did you just
say? Sorry. So, let me back up. I shouldn't be doing this in the same code chunk, I apologize. Okay, let's map this again. Okay, notice we have 2 different legends, right? One of them is named flowers because I named in this scale color, we're mapping to a legend that is named flowers. The shape here is mapping to a legend named species because it's defaulting to the name of the column. So if I want it to match, to be all in one legend, okay. Yeah, okay. Here. So let's name this species and see what happens. There we go. That makes sense, everybody? Sort of? All right. Any questions on that? I'm going to move on from this stuff a little bit. Well, more practice with ggplot, I promise. Okay. Because I wanted to show one other thing and still do R Markdown, and somehow I'm behind as usual. So the last thing I wanted to show from this lesson is 2 options for making multi-paneled plots, which is fairly common and something that is handy to be able to do. There's a really great package called cowplot. I don't know why he called it cowplot, but Klaus Wilke, I'm not sure how to say his last name, is a really great person who is really into data visualization, and he has a book out now that I've linked to down on the bottom of this under resources that he's working on data visualization. So if you want to read more about this, and it's all about ggplot and how to use ggplot. It's really cool. Cowplot is basically one of the options that is basically built into ggplot. So you install the package, you load cowplot, and I'm not going to have folks do this. I just want to show you what you can do. And then essentially you can make, so I've made 3 plots here using some base data, 3 ggplots. Notice I've assigned them as objects, right? And then I'm using this call to plot grid and then listing them in the order that I want and putting labels on them. And so you end up, and you can assign them what column, like if you want them by columns or rows, you can tweak that. But you end up with this very nice paneled plot, and that's the default, which is really cool. You can tweak this now. You can play with a ratio and how you draw it. So if you want to make your bottom plot really long, you can do that with this other option, this ggdraw and draw plot. So this code is here. we're not gonna go too much in more detail in this, but I do want to show you that this is a really nice option to make really, so I just used this recently for a manuscript that is going to get published, and we made these multi-paneled plots using ggplot, and it was awesome. And it was really easy to tweak it and play around with it, and I was really impressed. And you can export these using, it has its own function called save_plot, which is similar to the ggsave function that we've talked about. The difference is that it allows you to actually fix the base aspect ratio of a plot. And what that means, so you can play around with some of the things that, you know, the basic columns and rows, but changing the ratio actually can make a pretty big difference in how your plot is transcribed or whatever, how it looks. So this is a ratio of 1.1, and you'll see down here, here's a ratio of 1.5. And notice the difference between how things sort of are shrink down a bit more or a bit more legible. When you make the ratio larger, you can sort of see more, but it does shrink the text sizes down. So you kind of have to compensate depending on what you're after for that. Okay, one other option, which is similar to cowplot, but it's a new version or a new package, is called Patchwork. And this guy, Thomas Pedersen, you can only install it at the moment via GitHub. And he has a page I've linked to here. But similarly, you can do these multi-paneled plots. The difference is the terminology, the ability to do it, the code is much easier. It's like super simple because he has basically built it so it literally uses the same ggplot pluses. So you just add here's those 3 plots we assigned as objects. And I just said plus, 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 plot layout, 1 column. Or if you want to do multiple columns, you could do that. And then there you go. It prints it out really nicely. Even cooler is he has basically tweaked the language or the code so that you can play around and this is all on his GitHub page. You can, instead of a plus, you can nest these things. So say I want this one to be big down below. I do a plus for these two, they're up top, and then a minus for the one on the bottom, right? And you can do different, he has all kinds of different cool things where you can do like, just based on this little sort of signifier, how your plot looks, which turns out to be much cleaner code and much easier, but you have to read through it. I just want to put these up here as options for when you get to the point where you do start wanting to make a multi-panel publication plot. These are two really, really good options. And they're pretty well supported, so they get updated fairly regularly. And then there's some additional resources here if you want to read up on this. Hadley Wickham's Grammar of Graphics, this book, Claude Wilkes' book that I was mentioning. If you want to get a sense of less than ideal, let's just look at this, top 10 worst graphs. There's literally, these are from publications. Journal of Human Genetics, it's a plot that there's literally nothing in it. My favorites are these just single straight lines, like a 1-to-1, like, there you go, there's a plot. The 3D, the classic 3D sort of bar thing. The pie plot, which is pretty fantastic. Another classic Excel plot. Anyway, he honorable mentions for bad tables. So I expect now that you're all using ggplot, you won't even get close to this. So, but just to know how far we've come from sort of these, like why are these not very useful? I mean, you can look at these pretty quickly and decide for yourself, but I just want you to think about this when you start making plots that you're going to share with people. When you're looking at them for yourself, it doesn't matter as much because you're trying to explore your data and see a pattern, right? But if you're sending it to someone, you know, your professor or, you know, collaborator, it does matter, yeah.
Why is that bar graph? Yeah.
This one, I think it has to do, that's a great question. It has to do with the
Like the
labels or the bars or something.
Okay.
He has a whole thing where he talks about this, and I don't remember why. Maybe it was this part, yeah, right, like. Yeah.
But just like a bar graph.
A bar graph in general is not bad. Yeah, there's something else going on here.
I mean, yeah, there's a lot of things.
So anyway, if you want to play around, it's kind of fun to look at some of this stuff.
They're pretty much all.
Yeah, Mike.
Can you go to the number 10?
Oh yeah.
I did.
Number 10.
Yeah. So the first author of that paper.
Yeah.
Is the author of this.
This website. Yeah. He actually nominated his own plot for the worst.
Just to emphasize, there's no shame in having done things this way before, right? There's a better way that we're trying to show you. That, you know, that we think does a better job of sort of telling the story of, you know, building your visualizations in service to that goal of telling the story with your data. So yeah, no shame in having done it any of these ways.
Yeah. So anyway, okay. So let's switch over to R Markdown. So let's go back to the website and go to course materials and literate programming with R Markdown. Okay. So we've already talked a little bit about the visualization, talked about that. Now we're going to talk about communication. So R Markdown is this really amazing platform that's built into RStudio that you can make your own sort of document of any type, PDF, Word, HTML, using Markdown language. And just a show of hands, how many of you know what Markdown is or have used Markdown before? A little bit. And we've kind of dealt with it a little bit in our README files, right? But Markdown is basically just a way to translate plain text to sort of shorthand so that it translates into the HTML formats. And so there's some really great cheat sheets in RStudio that you can use. So if we go over to help, and if you scroll down here, there's a whole slew of cheat sheets. But you'll notice this one right here, Markdown Quick Reference. If I click on that, it actually gives you right there in the help, what are the different pieces of a Markdown. So this is fairly short, but it literally covers everything you basically need to know about Markdown. How to do images. This is, you add this little exclamation point and then sort of some alternative text and then the link. block quotes, code blocks, which I'll talk about more code chunks in a second, inline code, equations. So anyway, we're going to cover some of this in a second, but I just want you all to know this is all handy under help and markdown quick reference. Under cheat sheets, I also want to point out there's two different options. There's R Markdown reference guide and R Markdown cheat sheet. So let's take a look at this one first. So this is what is R Markdown. So all this stuff I'm going to talk about today, this has on literally 2 sheets or 3 sheets, 2 sheets. And so, and more, like a lot more. So I highly recommend after today, and your assignment is basically going to be, we're going to do an R Markdown document. So you're going to take code you've already used, and we're going to put it into it and make a full sort of report, right? Like if you were to report the ecology data set, you got it, you cleaned it, you filtered it, and then you made some plots, some publication-worthy plots in an R Markdown document. That's what our assignment's going to be. So this is a nice cheat sheet to keep track of, along with all the code that we've got up on the website and elsewhere. Okay. Any questions on that? Okay. So, all right. So knitting. So let's all go ahead and open a Markdown document. So if we go to up here, our script, our notebook, I'll talk about in a second, and R Markdown. So let's open a blank R Markdown document. So if I click on that, title doesn't matter, you can change it later, but let's say, you know, my first R Markdown, author. It's not your first, whatever. So you can don't worry about this. Let's leave it on HTML, but you can always go back and change this. You'll notice there's other options here. Presentations, Shiny is like an interactive dynamic app. And we can play with all those things, but let's hit OK, see what we get. Okay, so this is the first thing that pops up. It might seem a little overwhelming. I'm going to walk through the different pieces, but what I want you all to have open and be looking at while I'm talking about this is an R Markdown document. So this little bit up here, this knit, is the thing I'm talking about. If you look for the arrow on the right of that, this is where you can change the different options. Knit to HTML, knit to PDF. You may not be able to knit to PDF right away because there's another part of that that is required. We're not going to cover it today, but I'll talk to folks if they are interested. Knit to Word, if you wanted to do that, you can do that. Change that in there. And just to the right of that, there's a little gear, little wheel. Let's click on that. This is the part when you're actually looking at your stuff and you knit it. When you click that button, it's going to show a preview. You can either have it show up in a new window will pop up. You can maximize, or you can actually open it in a web page, which is also nice. Or you can preview in your viewer pane, which is usually over where your plots show up. There's a viewer pane right here, so it'll show up over here. Totally up to you. You can change it as you like. Similarly, you can preview images and equations and previews right inside here. So when we run a code chunk, which I'll talk about in a second, it'll show the results right below the code chunk. If you don't like that, you can turn it off. So this is the chunk output inline versus in console. Okay, so you can play with some of those options. Okay, so green stickies, if you have an R Markdown open and you have a sense of at least the knit. Okay. You don't have to do anything, just have one open that you can sort of be keeping an eye on. So, code chunks. So we're going to talk about code chunks. Essentially, that's the biggest thing about an R Markdown document. That's, I would say, the thing that makes it really cool. We can include our code. This whole thing, this whole web page, this whole website is built on R Markdown documents, which is really neat. So Mike and I basically will write these R Markdowns. We knit them into a web page, and then it puts them all together like this for us. So when you're looking at this, this is the text in between the code chunks. Okay, what does that mean? What does that look like? Well, let's go over here. So the header, this part, is called the YAML header, Y-A-M-L. This is the sort of the bit that tells when you click knit. This is what it it uses to determine what kind of document you're making and how's it going to look. And there's a whole bunch of nice little options we can play around with really quickly that I'll show you in a second. But mainly right now, it's just going to put a title, an author, a date, and then this output. So this is where it would change to something else if I wanted a different output. Below that is a setup chunk. You don't need this, but this is sort of the default, like think of global preferences, right? So across all of your whole document, if you want your echo, all your code to show up, so that's what echo equals true. So it's basically setting that as a default. For now, let's delete that. We don't need it because I want you to just see how this works. So let's all click knit. Oh, it makes you save this first. I'm saving it in docs because it's going to be a document and it's not a script. So I'm going to click knit. And then this is going to pop up. Okay? So here we go. Here's the text in between these code chunks, right? And then it embeds your plots. It does all this different stuff. I'm going to show you some other tweaks that you can make. A code chunk. This is a code chunk. To make a code chunk, there's a shortcut, or you can go up to this button up here and click insert. Notice there's for different versions, but you can actually add code chunks with different code in them, which is pretty cool. So if you have Python or Bash, you can actually put that in there and it'll interpret it as that language. For us, we're using R. So our code chunk is going to start with R. So let's add a code chunk here. Insert R. There we go. Blank code chunk. I'm going to actually jump over and grab the plot we made up here. This one. Or maybe it's this one. I don't remember. Whatever. Doesn't matter. I'm going to copy and paste that right into my code chunk. Okay? And I'm going to actually make this color. It'll look nice. Now, if I try to run this, let's try to knit this and see what happens. Now I've added a code chunk. Here we go. There's an error that popped up. That's because there's no function ggplot. You have to load the library inside your first chunk. So anytime you have an R Markdown document, the first chunk that you load the library, whatever that library is, it's available for the whole rest of the document for the most part. So whatever your first chunk is that you're using code, you want to make sure that you have your library ahead of that. Yeah, wrong hand. Tidyverse. Okay. So now let's try to knit this. There we go. Now you see it's chunking through things here. Output created. There we go. Now notice it has this whole like library tidyverse, attaching packages. It's printing all this stuff out. I'll show you how to turn that off in a second. And then it shows the code. And there's my plot right in there. The cool thing about this is think about if you're typing up notes to yourself or you're sending a report to somebody, you can just keep your code right in there. You can tweak it and then hit knit and you're done. You don't need to like export your figure, insert it into a Word document, and then when you're like, oh, I need to change that thing again, you have to go back, fix the code, export the plot, put it back into Word, right? That's the advantage of this, is it's all in one thing. So it's really great for like lab notebooks, little reports. I mean, I'm writing a whole manuscript in R Markdown, to be honest, and it's been pretty cool. It renders to PDF, but it makes it really easy to do that. If we want to just show the plot and not the code, there's a bunch of options inside the header of this chunk, this code chunk. So if I hit tab here, right after the R, there's a whole bunch of things that pop up. I'm not going to be able to go through all these. That's where that cheat sheet is handy. But the couple that I'm going to point out are as follows. Echo. So what do you think echo means? Yawn. Big yawn. Echo, true or false?
It writes,
Shows the code or not. Exactly. So echo equals true, it's going to show my code. Echo equals false, it's going to run the code but not show it. Right? So let's do false so we can see. And I can add even a note. Let's put a note here. Let's run some code, but set echo equals false. Or yeah, false. So the code doesn't appear in document. Okay. False.
You can still put that as like a hashtag in your.
You could put it in a comment in here, just
Yeah.
like normal. Totally. Yeah. But now
Because
I'm.
if you put it outside of it, then it will show up. Like that line.
Exactly.
Will show up.
Yep. So now see, it says let's run some code, but echo equals false. So notice the code's not here, but what is still here? The loading package thing, right? Which is kind of annoying. Like if you want a clean document, you don't really need to see all this. So that's where that, I don't know if you remember, there's a few functions that are available for this, but the one that works well is suppress packages. Suppress, there's a whole bunch. If you type suppress and tab, package startup messages. This is the one I use. And then you essentially wrap your whole library call, or calls, you can do multiple libraries inside of this, in that. Okay? Now if I click knit, there we go. So now we just have a nice plot, no code. Cool, right? Any questions on that? So echo, show your code or not. What about if you want to show your code, but you actually don't want it to run? You want to say like, hey, this code is broken. I don't know what's wrong with it, but I want to show you the code. How might we do that? Well, there's another flag or argument inside of this. So let's make another code chunk down here. Let's make a section break. So 2, 3, it doesn't matter. 1, 2, or 3, we'll do the different headers, right? So show code, but don't evaluate intent. So to make a new code chunk, you can use Command or Control Alt I on mine, or again, go up here and hit Insert R. That's what I got this. So again, I'm going to go down here and now evaluate. Turns out there's a eval command here. Okay. Same thing, true or false. So false, I want the code to show up. So let's go ahead and copy some code in here from above and run this. Now I've added this additional section, which should show up in nice big bold letters. So including plots, show code but don't evaluate. So here it's shown my code, but there's no plot below it. Okay? So eval and echo, I'd say those are the two biggest ones that you might want to play around with. And there's a whole bunch of others. Okay. Any questions? Yeah, go ahead.
So if you're trying to load multiple libraries,
Mhm.
that
What would that?
what?
Go ahead.
How do you do that? Because it wouldn't let me put like a semicolon. Like normally I would just do the same line
Right.
of code, but it won't. It can't pass an error if I did.
So for multiple libraries, I use a squiggly bracket, and then you can use semicolon, library, here it is, let's say whatever library, I don't know, ggplot, even though it's already loaded, we'll just do it. And then at the end, we have to close those squigglies and the parentheses. Yeah, that's a good question. So then it will load all of those and suppress the messages for all of those. Okay, let's switch back over to here. Okay, so I have some examples in here with a new data set that we haven't played with. It's part of the ggplot, I think, actually, or tidyverse. But it's basically hurricane data, storm data. And I've made this plot, embedded it, which is pretty nice. You can take a look using the Viridis package. What the code looks like is here. You might have to change this _C. I apologize for that. So we've just talked about how to print code or how not to evaluate it. And and how to suppress package messages. So we sort of blew through our challenge, but that's all right. I want to show you really quickly web links. If you want to add a web link as a hyperlink, you can use this format here, hyperlinking, or just add your full web link. Photos and images. So again, this is in that cheat sheet, right? So if you wanted to insert an image, make sure your path, the biggest thing is the path is often the thing that breaks or is not correct. So if it doesn't show up, it's probably because the path needs to be double checked. Same thing, you can do GIFs and videos, which is pretty cool. So we've all felt like this. And here's an example of last week's screencast. And this is this, I literally went to YouTube, clicked on the embed link. There's like a, where you share, and then I copied their code and then just put it right into the R Markdown. And then it makes this nice, like you can change the size and make it right there, which is pretty cool. So you can embed a video. The last few things here, equations and formulas. I'm not going to go into too much detail, but there's a language called LaTeX. Some of you may have heard of. You can do whole documents. So I would say the two sort of major tracks that are not Word currently are LaTeX, which is like on the, what you can do with it is amazing scale. Learning curve is also just crazy. It's like ice climbing. If you've never done it, it's going to take a while. R Markdown is happily in between. You can do a lot of really cool stuff with it, but it's much easier to learn, okay? So LaTeX is great if you're interested in it. But what we can do is borrow some of the code from it to do these equations, right? So you can do formulas and equations basically with setting these dollar signs. You put everything in dollar signs. And you can look up sort of, I would often Google, like, how do I do, equation for whatever it is, sigma, and then it'll give you the code. Tables. So we all have to do tables in one fashion or another. There's a really handy package. As long as your data is a data frame, and we've talked about tidy data, but if it's a data frame, this package is part of Knitter, which is actually installed often as a base package in that does the knitting for your document, right? But cable is the function. And so if we wrap any given data frame, so I'm taking the head, just the head of storms, adding a caption and wrapping that whole thing in this cable with a K, and it prints out this very nice table, right? Pretty simple. Another option is this HTML table, another package called HTML table. Same thing, you can just put a data frame right in there and it prints it out as is. And you can tweak this to your heart's content if you're interested. If you want another option is, these web pages are great. If you have a crazy huge data set, thousands of rows, you're not going to put it all, you don't want it to all print out in a table, right? If you have the option, you can use this other package called DT, which actually is an interactive table, which is much more like actually RStudio, right? Where you can query, you can even type in here, hurricane, and see what pops up. And it will filter automatically to that data. Or if I want to pick a year, it will do 1999. Right? It just filtered everything that has a 1999 in it. It's pretty cool. And down below, you'll notice there's a whole bunch of, there's like 10,000 records in here, and it has each one as a different page, so you can click through. So this is actually a really handy way to share big data sets with folks if you want, and you can surf around. And I use this all the time just for exploration too sometimes. You're trying to query your data. Oh, what happened? Okay. Footnotes, there's another, you can include footnotes. Interactivity, this is the part I really wanted to get to at the very end. So there's a package called Plotly. Let's show the example and then we can try to get people set up with it. Essentially would install the Plotly package. I'm showing the code here. You load Plotly, and then this is the whole function is ggplotly. So we can wrap our whole ggplot, any ggplot this works with, in this ggplotly function. So you take ggplotly, parentheses, your ggplot code, and then when you render this, when you click knit, it's taking a minute because there's a lot of data in here, this is now interactive. So I hover on any of these points and I can click on it. It will actually tell me the actual data in that point. Here's the even cooler part. You can click and zoom on any given part of this plot. and it will zoom right into that, and you can surf around and look at some stuff. You can zoom back out by double clicking. It will zoom back out to the full plot. Okay, this is singularly one of the really cool things that I found that you can wow people with, right? The other cool thing is, I can't do it with this data set, but you can do, if you had multiple data sets over here, you can actually turn them on and off, which is also really handy. This is really slow right now, I apologize. So you can turn those on and off. Okay, the last thing, or penultimate thing, maybe. Maps. So you can make an interactive map using that same data set. Don't worry too much about the code. We will have time potentially as one of the options to cover mapping in R. There's a whole bunch of really cool things. Leaflet is the package I'm using here, and there's another one called Map View, which is even easier. But I'm taking this same data set that we had, this hurricane data set, and basically mapping across the latitude and longitude, and then doing some color based on the wind speeds. And there you go. And what's really neat is you can turn these layers on and off. And this is a full Google map, right? So I can scroll in, I can look at these. Later down the road, you can actually click on any given point and it'll pop up all the data for that. This is a really powerful, awesome tool if you work with spatial data, or even if you just want to make a map to share with somebody of your sites, right? Like, where did I sample or where am I going? You can throw one of these together really quickly, okay? And finally, citations. I think it's a little bit more in detail than I want to go, but you can actually add a .bib file, for those of you who are familiar, but it's just a file that you can export for most any. Zotero, Mendeley, EndNote all have that option. You include it in your header, your YAML header at the top of our document. Remember up here? So you would add another like bib equals and whatever your file is. And what's neat is, and then it has the option, RStudio has a very nice overview, that will build automatically your citations for you. And right at the bottom, you can scroll through this, but that doesn't even have it. But you can also add styles. So this is what I was trying to find. So here's my bibliography in my header. And then any format that you want, you can go download these for free. So just go find the format that you're interested in, and it'll print it out in that format at the bottom of your document, which is really cool. Okay. As now everybody's like, oh, whoa, this is a lot. I know we sort of flew through that. But I just want you to know that the flexibility of this makes it really, really powerful, and what is possible is quite a bit. So for our assignment for this week, we would like you to, and we'll put it up on the ENTS discussion board, we'd like you to make an R markdown and put code from last week, or I don't know, we'll figure out what we want to do. I think it's a pipeline. Basically, it's stuff you've already done, right? But we want you to then try to make a publication, what you think is a good publication-worthy plot at the end. So sort of walk us through what you did, like why we're doing that, and then end with a plot that tells some sort of story. And then here's the part. We're going to do the same thing where we exchange code. When you push your code up to GitHub, don't push the HTML file. And that's because the HTML file will not render on GitHub. It'll just look like you're in the matrix. I'm not good at reading matrix code. Most of us are probably not. Just push the R markdown, the RMD file. So let me show you what that would look like. And there are ways to do this. So if I go to my Git tab here, and I click in Docs, right now there's a whole bunch of other things, but the main thing, let me uncheck all these. So notice there's two different files here. Whoops. There's a RMD and an HTML. If I push both of these up, that's fine. I mean, there's no harm done, right? But if somebody clicked on that HTML file, they're just going to see matrix code. So what you want to do is just keep that for yourself. And then the nice thing is somebody can take your code, and assuming they have all the same pieces, they can knit it themselves and look at it on their computer, right? Alternatively, one thing I have done for folks that may not use R, you can actually just save that HTML file as a standalone page and just email it, zip it up and email it to them as well. So that's a way, like, you wanted to share these reports, you can do that as well. Keep in mind, if you have a bunch of interactive like Plotly and maps and stuff, that HTML can get really big. So I wouldn't do that as much, but for most stuff with figures, they're pretty small. Any questions? I wanted to leave time at the end to talk a little bit more about this and then talk about the assignment for this week. Do you have anything else, Mike? I know I flew through some of that.
So the RMD document that you've been typing, there's another live code link now in the Google Doc that represents everything that Brian was typing.
Sweet.
Just as the live .r.
Awesome.
But now, otherwise it's not.
Yeah.
One thing I'd add is that like all the cool stuff you just saw how to do in R Markdown. The nice thing about R Markdown is there's no magic steps involved where Ryan is like doing something behind the scenes and all of a sudden cool stuff happens in his R Markdown. You can look at the .rmd document and you can see, okay, here's how he added that GIF. Here's how he added that map. Like you can see it in the document. So I think it's a really cool thing to just go look at someone else's .rmd. If you find something cool, you're like, oh, I want to add something like that. Go to their .rmd, go to that chunk and look, what did they do there? And you can just copy that.
That's a great, really quick, let me show you. So let's go to this web page that the R Markdown we used to build this web page. So I'll add the link to this in the Google Doc, or maybe we can do that. So this is all on for building our website, right? So where is it? Lesson R Markdown. So right there. So if I click on that, take a minute. This is what it looks like. So when you're actually getting this code, this is what you'll see. And you'll notice some of these things will actually appear. They render pretty nicely in the R Markdown. GitHub has been getting better at rendering R Markdown. And so here's what it's like semi-rendered at this point. Like it actually includes the GIF, that's cool, but not the Google YouTube. And it does not include the interactive plots. If we want to see what this actually looks like, you can either download it, or if I click this raw button here, this shows the actual raw code. So this is the actual code. Like if I were to copy and paste, I would just copy this page or save this page to my computer. If I right-clicked and save as, I can then save this R Markdown to my computer and try to run it. But if you want to see all the code that went into that page that I just showed, that we just walked through, or any of the pages really, you can do this. You can take a look and see how we built them, right? And how we made certain things look like, how the challenge looks, or how the different section headers are bold or italicized. I highly recommend look at other people's R Markdowns because you learn a lot. There's people do some really cool stuff, and I found little things I didn't know you could even do just by scoping out other folks' R Markdown. Okay, that's great. Yeah, and somebody in front. Yeah.
Yeah. So, I mean, you could write your entire dissertation in R Markdown. Yeah. Do people do? But it just seems like hurt my eyes.
It depends. Yeah. So.
Like functionally, how do people write their dissertations in Word and then paste it over to?
That's a great. Hang on a second. Let me show you.
There's no spell check.
There is actually.
There is.
There is spell check. Yeah.
Okay, then I'm fine with it.
So here's an example. I totally agree. I'm not recommending that everybody writes their dissertation in R Markdown. I think it's really, if you want to, you can. I think it's a whole different ball game. Here's a manuscript. This is my chapter 2.
Yeah. No.
So so here's the thing. You do this once, right? This is the YAML header. You do a bunch of fancy stuff in the YAML header, like your abstract, your blah, blah, blah. Here's my bibliography and my journal type that I want to use, and then some other stuff. And then after all this, there's just typing. Like that's it. And then when I actually just type.
Opened RStudio.
Yep.
And open an R Markdown.
Yep. I actually do this to make it bigger. I actually make it like full screen so that you can pop this out and make it like its own window and just take. So I do that frequently, but I don't really do much else than that. And it's pretty. I've been surprised how fairly easy that is. I don't know. I agree it's not for everybody. So yeah, go ahead, Taylor.
How do you make sure you don't have typos and grammatical errors? Like, where does that fit that? How do you make RStudio?
Right, so there are add-ins. There's actually different add-ins over here. There's word counts, readability. So these are all things that you can look for. There's actually a spell check that this has. So the other thing is, because it's so easy to render, I'll click and render it to PDF, and then I can do like, send that to somebody and they can read it that way. I think to each their own. I'm not advocating this is for everybody. This is an experiment for me as well. So it's sort of, ultimately, the funny thing is I'm doing this for one chapter and I'm doing a Google Doc for another chapter, because that's just the people working on it. We're like, great, send me a PDF like 1,000 times, or no, I want a Google Doc. I'm like, okay. So I think having that flexibility is pretty cool. Yeah.
Well, I was just gonna say, yeah, so if someone doesn't use R and you want, like, let's say your advisor doesn't use R,
Yep.
and you want to send them something, like this would not be a good way, because then you're sending them just a straight PDF, because you can send them the R markdown, right?
Yep. So like I sent this, let me show you what this looks like when it's done.
Which if they need to edit it, it's probably not the best.
Right. Well, actually, so it depends. Like my advisor has been like, he's like, great, send me this, and he just hand edits everything on this and sends me like a hard copy.
Whoa.
That's what he's comfortable with at this point, right? Like as we get, but this is what it looks like when it's rendered. So it's a full-on document. It puts all the figures, like in a manuscript that you're going to submit. It puts all the citations and the list of figures. It does this all automatically, which is a nice thing. I don't have to fuss with this. Every time I go, just regenerates a figure. Here's some multi-panel figures, right?
You cite every package that you use?
That's a great question. I try when possible, if it's like a package that I really feel I'm really using, certainly. And I think more and more, it's hard because some journals are not like real keen on that. Others are, and I think people should be citing the packages because there's a lot of work that goes into making them what they are.
Like in this manuscript, you cite
like tidyverse probably, and then potentially some of these other like graphical, a few of the other things, or like for the analysis, like anything that's a package that I used statistically, I certainly cite those too. Yeah.
You just mentioned them in the method.
So yeah, like I did to make this, I used blah, 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 and here's a citation. So you can cite all the packages. I think there's a command like cite, or you can look up the packages will give you a citation for them if they want to be cited.
I just had that as a whole separate section in my methods. Like, here's the packages that I use, here's where my data are. That's
yeah. Depends on the journal. Yeah. So anyway, I recognize this is not for everybody, but I do want to show you that this is possible, right? You can make I do my CV in an R Markdown, which is really handy. Actually, that one is really much easier, I think, to manage. So yeah. So anyway, feel free to ping us, hang around if you have questions, and then we'll look for that assignment, an email with the assignment details. And thanks, y'all. And Phil, can we do the end of class survey, please? And a little survey about what you want to get out of the last few weeks. So survey forms there, yeah. Oh, okay, don't hang around. So we got to evacuate premises. I feel unsure about myself every day. Sure. We go over there. All right. So if anybody wants to talk afterwards, we'll go over on the other side. You walk through, and there's a little lounge over there.